So today I'm gonna talk about the titration curve. Basically, there are 4 types of titration, and just look at the starting point, which is that, and this thing start like this is the pH, the 7 right here, and this start point like very below it. So this thing start with a strong acid, and this thing like just slightly below it. So then this is gonna be a weak acid. And when they add with a strong base. The same thing, strong base. And this thing like right up here, which is like 14 or something, like 10, 14-ish. So that gotta be start with a strong base. Add a strong acid. So this one right here, just right above of the pH of 7. So then it's gonna be a weak base plus a strong acid. So the purpose of these things is helping us like do calculation and stuff. So like we can solve for random acid or random bases. And yeah, so then this thing right here, when look at these things, we will look for the equivalent point, which is like, can you see like they have kind of like a segment of straight line-ish. So with a strong acid and a strong base, they will become 7. This is their equivalent point. So then we're gonna have, so the number right here gonna be the amount of strong bases that we added. So then we can use that and apply for the math. So this is called a equivalent point of that. So this is a strong acid and strong base titration, and this is the weak and the strong. And as you can see, the kind of like the segment between us is that. So then we can pick the middle. We're gonna pick the middle one. Go downward. So then the number right here gonna be the amount of strong base that we added. So then go that way, we can see that the pH is above 7. So that the pH of, so the equivalent point of this weak acid or strong base will have a pH of greater than 7. This is pH equals 7. They work in the same logic with that. So this is a strong base, strong acid, and the equivalent point gonna be, see that segment line, it's gonna be 7. Because the H and the OH will like be together, then they will be all neutral. So basically, oh hang on, I'm being so random. So right here we adding OH. See, so if the H and the OH are the same, we will have neutral, like water. This is, if the H is smaller than OH, we will end up with a more basic solution. This is a strong base and strong acid, so it work the same way. We add H plus minus. We add H plus, so basically they have the same amount of like hydrogen and hydroxide, so then they're gonna be cancel out, become neutral. So then the pH of this one will also be 7. And right here with a weak base is a strong acid. See, as you can see, the starting point like right above 7. So that means is a weak base. Oh, I said it. Okay, so then the segment, I mean, this like kind of like more that way. So like we will have the straight line right that. So then we have that. So then the equivalent point will be right here, like below 7. This is the amount we're gonna add to get that. And then the pH of this thing gonna be less than 7. They work the same way because they add hydrogen. So if the number of hydroxide and hydrogens is not equal, the hydrogens is more, they become more acidic. So that. So the main purpose is using, we have to learn how to use this graph because we have to decide what type of indicator we're gonna use for our solution, because like we look at that to see like which one would be a better fit to be the indicator for the solution. Beside that, we can use these things to collect information and plot out thing to like to solve for random mysteries acid or basics. So then we can add those record number, like make up the curve and then use that to decide is that a weak or a strong, or is that blah blah blah. Yeah, is that how it works. Oh, my name is An Nguyen, by the way.